going to be given by Maximilian Kohler from Ruhr University in Bochum, and the floor is yours.
Right. Thanks for the introduction. So today I present joint work with Claude, Markus, and Fatma towards implicit visual memory-based authentication. When it comes to authentication, there are challenging and even more challenging solutions, because it's always hard to satisfy the needs for security and usability at the same time. To make clear what the problems are, I want to introduce the 3 common factors for authentication. So usually there are knowledge, biometrics, and possession. With knowledge, I mean something you have to remember. A popular example are passwords and PINs. For biometrics, it's fingerprints, face, or ECG, as you have just seen. And for possession is something you need to carry around, for example, a hardware token. If you want to reinforce such authentication, you can, for example, combine 2 factors. We call it 2-factor authentication. Then there is risk-based authentication, which was introduced last year at NDSS, and there are solutions that continuously sense the user and authenticate them. If you want to have an example for knowledge-based authentication, let's look at passwords. So for passwords, a user has to create a secure password, remember it, and provide it at time of authentication. So usually a user has problems with all of those 3 steps involved. There's a very high cognitive burden involved if a user tries to remember a password. And the consequences are password reuse, so a password is used on multiple sites, and password resets. If we have a look at password resets, we have a look at fallback authentication. Fallback authentication is used to regain access if the primary means of authentication is lost. So fallback authentication is quite different to primary authentication, for example, in terms of memorability and rate limiting and the time required to authenticate. So a fallback authentication secret needs to be memorable for longer time frames. Rate limiting is more relaxed or more strict, it depends, and time required to authenticate is different as well, so it can take longer as it's not used that often. Fallback authentication is often the weakest link in the chain. There are popular examples for this. And if you have a look at the security questions on the right-hand side, they are considered quite insecure. The answers to those security questions can be guessed easily, and thus we need to design better systems. Before I start my presentation, I want to play a little game with you. So please focus on the slides and try to identify what can be seen in these images. I will give you a few seconds, and then I will show the solution. So in this case, it's bells, right? Quite easy. If you can't recognize this, I have another example for you. What can be seen here? Take your time, and I will show the solution. It's cows. Okay? The images you have just seen are so-called Mooney Images. They are thresholded 2-tone images showing a single hidden object. They are hard to recognize, that's the problem you just encountered, but the recognition is sudden. We call it eureka effect or aha effect. You just get it, it clicks. And you can recognize them intrinsically by marking the contour of the hidden object or by showing the original image as I have just done. You wonder what the value for authentication is with these Mooney Images. They trigger brain processes involved in implicit memory. So what is implicit memory again? Implicit memory is there for unintentional recollection of information. Examples include riding a bike, playing an instrument, so habitual behavior. We are not aware of the information stored in our memory, but we can trigger the implicit memory by a process called priming. And as you can see on the right-hand side, this priming effect or the effects of priming can even be visualized using fMRI brain scans. So we built an authentication system out of Mooney Images that relieve the user of the cognitive burden of remembering an explicit password. The authentication system consists of 2 phases. In the first phase, the enrollment or priming phase, the user is primed on a set of random Mooney images, and we show every image twice. In the authentication phase, There are primed and non-primed images. So Mooney Images the user has never seen before. And the user is requested to label those images. A scoring algorithm based on the surprisal of the observed events measures the performance of the user, and if the score is higher than a threshold or security level, the user is authenticated. In more detail, the enrollment or priming phase involves the smooth transition between the Mooney image, then the grayscale original image, and above of it a label, and then the label stays there and the image fades back to the Mooney version. This process takes approximately 3.5 seconds, and in our user study we used 10 images which were primed on the user. In the authentication phase, we present primed and non-primed images, and the user is requested to label them. In the case there is a non-primed image, then the user has the option to press the I don't know button and skip the image. And our assumption here is that a user labels a primed image more often correctly than a non-primed one. Our scoring algorithm is based on the self-information, sometimes called surprisal of the observed events. You wonder what events there are. There are the primed image correct label event, primed image incorrect label, non-primed image correct label, and non-primed image incorrect label. We call the primed image correct label event P and the non-primed correct label event N. And then the only thing you have to remember for this talk is that a good Mooney image has a very high P value but a low N value. So the probability that if the image was primed is labeled correctly is high, and the probability that the image which was not primed is labeled correctly is low. In our attacker model, it's quite different. The first assumption we always get is, hey, I have recognized what can be seen here, so I have hacked your system. But it's different. The security does not rely on being able to recover what can be seen. So if you are clever and able to write a computer vision algorithm that can recover what can be seen, it's no problem for us. In fact, we make it easier for you. So we provide the attacker with the Mooney image, the original image, and the label. And still, the attacker is not able to impersonate a user. In fact, the secret of the scheme is another one. So the secret is knowing which image the user was primed on. And the good news here is that this secret is selected on server side. So there is no user selection bias involved. The only chance the attacker has is random guessing. He has to guess whether is this image primed or not. Does the user know what can be seen or does he not know? And obviously, we limit those guesses with rate limiting. So the question is, does implicit memory-based authentication work? And before we come to results, I first introduce our user studies. We conducted 3 user studies, so a pre-study with 230 participants over a time span of 20 days, a long-term study with 130 participants over 8.5 months, and a main study with 70 participants over 21 days. The goals were quite different. In the first one, we tried to get the P and the N value for our scoring algorithm and test the label matching algorithm we use. Then in the long-term study, obviously, we want to see the long-term effects, and the main study get a performance measurement. So in previous work, they used sketches or line drawings of objects and erased some important parts of it and primed the users on it. And here you can see their results, and to compare with our solution, I plotted our results above it. So here you can see the performance of the Mooney version. On the x-axis, you see the p-value, so the probability if the image was primed that is labeled correctly, and on the y-axis, you see the probability n, which is image which was not primed is labeled correctly. And you can see that we outperform previous work. So implicit visual memory-based authentication can work. And then is the question, how long does it last? Well, we have 3 timestamps we measured. The first one after 9 days, and he is visualized here. Then after 25 days, and after 264 days. I repeat it to make it easier. So as you can see, the priming effect declines over time. but the decline is moderate. And a good news here is we can reprime the user at every login. So instead of showing all 10 images, we can just show a single image, and by this we can even extend this priming effect. Then there are some limitations and benefits of MooneyAuth. First of all, a benefit, we have a very long memorability, as you have just seen. The secret is server selected, which involves no user bias, which is great news. However, there is the limitation that it's quite cumbersome to label. So the user needs to label those images, and if you have a software keyboard, then the time required is quite long. So in our user study, it was 3.5 minutes. Which is something which is still unexplored is the interference effect. So what happens if you use MooneyAuth at different services at the same time? Maybe your brain got confused with the images. We need to test this. And then there are the common vulnerabilities of many authentication systems. First of all, phishing, shoulder surfing, and then the problem of the secure storage of the secret on the server side. So let's play again, back to the game. I hope you all remember the solution. So what is this? A cow, right. Easy. And this one? It's different, right? This image was not primed, so it's okay that you don't recognize. In this case, the user just pressed the I don't know button and skips the image, but it's an elephant. Okay, so the takeaway of my talk is that there are Mooney images, and they can be used to trigger the implicit memory in your brain. And with this implicit memory, you can build an authentication system that relieves the user from explicitly remembering a password. And if you are curious and want to see more of those images, you can visit MooneyAuth.org, where we have a prototype implementation. And with this, I'm finished, and if you have any questions, feel free to ask them now.